Welcome to day 3 of Advent of Code, and this time we're going to be looking at some binary numbers. So in this case, I've kind of pre-read the problem here. We have this input, which consists of a list of binary numbers, and what we want to do is we want to take the most common binary digit, so either a 0 or a 1, in each column, and use that to construct our final binary number. So they kind of go through the example here, but basically you look at the most common number in this first column, which ends up being a 0. And so the first digit here is going to be a 0. You do the same thing with all of the columns in the binary digits, and you end up with 10110. At the end, you convert this number to a decimal. And so, let's see, that's the gamma rate. And then the other way is you do the least common bit. So you essentially just invert it. And so here you see there's 10110 and this is 01001. So I actually think we can just convert one or the other and then just invert it. And then I think at the end, they just want us to multiply those together. So to start, let's get our puzzle input. And one quick scan through I just want to do to make sure like all the lengths that are similar based on like how I'm going to write this code. And it looks like they are. So that will make some of our work easier for us. We won't have to handle these edge cases. So let's go ahead and save that input and work through it here. Here you actually notice what I don't want to do here with my template code is I have this line here which says to map each line as an integer and actually represent it as an integer. We actually want to keep this as a string, and that's how we're going to work with it. So we actually don't want this line here. So we will create a function and we'll call this what do they want? The power consumption. And this will take in a list of numbers. And then for each number, ignore GitHub Copilot here, but for each number that we're given, that's again each row here, let's maintain one, our final digit string, and then for that we're going to use, we're going to replace each item in that array. So first, let's go ahead and get the length of the digits. So we're going to say numbers of 0.length. That'll give us the length of each of the numbers. And then next up, what we want to do is we want to say our final string, and we'll call this gamma, is what I think they call it, the gamma, what do they call it? The gamma rate. And we're going to store this as an array. And I actually want to go ahead and initialize this all to zeros. I actually don't know how to do this right away, so initialize array with size and values. Awesome, so here's how you do it. So I knew it was like using the array syntax here, but we know the length of it, and then finally we want to fill them with all zeros. Great. Now we're going to go ahead and go through our numbers list. In this case, we're actually not going to go through length. Again, we should just really ignore how this all works. Let's see. So instead of length, we're going to use numbers.length. And so here what we're doing is running through every single row. And then we're going to say for each row, and all the lengths are the same, we're going to say, what I'm going to do here instead is say gamma of j. If it's a 0, I'm going to subtract 1 from gamma of j. And if it's a 1, I'm going to add 1. And essentially what this does is you end up with either a positive number or a negative number. And so based on that, at the end, we'll go through and normalize those numbers. If it's a negative, we'll change it to a 0. And if it's positive, we'll change it to a 1. So let's go ahead and do that. So we say if numbers of ij is equal to a 0, then we're going to actually subtract 1. And else we're going to add 1. And then at the very end of this for loop, we're going to go through our gamma map, and we're going to say map it, and basically if x is greater than 0, then we're going to return a 1. Otherwise, we're going to return a 0. That should give us the gamma. Now, the epsilon rate they mention here is basically the inversion of the gamma rate. So we're going to say epsilon is equal to the gamma dot map. And we're going to go ahead and do the same thing. And if x is 1, then we actually want it to be 0. And if it's 0, then we want it to be a 1. So we'll go ahead and map that. Now we have our gamma and epsilon. These are actually mapped as arrays. And what we want to do is we want to actually join these into a string. So we'll say gamma equals gamma dot join. And we'll join these basically with no kind of separator in between each of these. And we'll do the same with epsilon as well. And then at the very end of this function, we want to return those two multiplied to each other. And we're going to call parse int here. And we'll pass in gamma to an epsilon 2. The second number here is the base. So again, these are binary numbers and binary representations of the numbers. So we want to return the binary digit and then parse that as a 10-digit integer and then return a base 10 number. So let's go ahead and do that and actually see what we end up getting. We're just going to go ahead and test it, I guess. We got 4095. Let's see if that's correct. Okay, not the right answer. So let's go back and let's go ahead and test with just this input. So what I'm going to do here is I'm actually going to touch test and then code test. And that way we can just paste this test input in here. And in here we'll go test and see what we get when we run it. So we get 31 here when the real answer should be 198. So let's go ahead and print here each of gamma and epsilon. Let's see what we get. So we get 1, 0, 1, 1, 0, which is exactly what we want, and then we get 0, 1, 0, 0, 1. Okay, which is actually good. And then we want to return, I see here I'm doing plus, I want multiplied by. And so now we get 198, which is actually the correct answer for our test input. Let's go back, do this for the real input. And now we get a much larger number, which is probably correct. Paste, submit, and that's part 1. Awesome. So we'll move on to part 2. Okay, next, you should verify the life support rating. Okay, which is 2 other ratings. Okay, so let's see. To find the oxygen generator rating, determine the most common value in the current bit position and keep only numbers with that bit in that position. So if 0 and 1 are equally common, keep values with a 1 in the position being considered. Okay. And to find the CO2 scrubber rating, determine the least common value. And if they're equally common, then keep values with a 0 in the position being considered. Okay, that seems fine. And then we do that number. And then I see, so we kind of do it like again and again. So it seems like a recursive idea. Yeah, here. Otherwise, repeat the process. Let's see. And that's true for both of these. Let's see. So the least common and the most common. Okay, so what we have here is a function where given a list of numbers, it can return to us a binary digit representation of a function that shows the most common and the least common values in each column. So instead, what I'm going to return here is the gamma and epsilon values. And we're going to move this back to test so that we can confirm with our test input here. So this function gives us the most common bits and the least common bits in each column. Let's make sure that we are returning the correct ones. Here in the default case, you see here it does say if they're equally common, then keep values with a 1. So here we say if it's greater than 0, then return a 1, else return a 0. And here we want to say if it's equal to 0, that's the case where they're equally common, then we want to return a 0 or a 1 for the oxygen generator rating, the one that checks most common. And then epsilon will do the opposite of that, and I think we actually end up doing we want greater than or equal to 0 here. So if they're equally common, meaning x is 0 at the very end, then we return a 1, and epsilon will be the negation of that. So I think we needed that equal to 0 there. Let's make sure this doesn't change our test answer. Let's actually keep doing return that parse int line that was here. Okay, so we keep 198, which is good, regardless of that greater than equal to change. We're going to return only this array, and we're actually going to use this over here. So the final value is what? The life support rating. Okay, so we'll call this life support. And this also takes in a list of numbers. And one thing that we want to do is we want to say const get the gamma and epsilon values from power consumption. I'm going to actually reduce this function now because we're not going to need it anymore. And then given these numbers, now we're going to go through all of the number inputs and either keep them or remove them. And let's see how we do that. So we get this, the oxygen generator rating. Let's see. Start with all 12 numbers, consider the second. There's more. Okay. As there's only one number left. Let's see. Start with all 12 numbers and consider only the first bit of each number. Bits and 0 bits, only keep only the 7 numbers with a 1 in the first position. And then there are only second bit, there are more 0 bits than 1 bit, so keep only the 4 numbers with a 0 in the second position. Okay, that sounds good. What do you end with? 1 0 1 1 1. Does that have any relation to this? 1 0 1 1 0. I see. So you stop when there's only one number left. Okay, so we'll go 4 and gamma epsilon. I think what we want to do is not get this anymore. We want to keep that array, not a string. So we'll say 4, and we'll do I in gamma's dot length, and gamma dot length. So now we're looking at, we're doing this. We're looking at the first bit of each number. And so we'll say if, and we'll go while numbers dot length is greater than 1. If it's equal to 1, we can stop. And if, let's see, if numbers at I, so the digit that we're checking, is not equal to gamma at I, then we want to, I think numbers dot shift removes that value. Yeah, remove the first element of the array. Okay, fantastic. We actually don't want to do that. We want to just remove that number that we're looking at. Let's see. We'll say for each digit in the gamma, so now we're looking at this one, keep only the 7 numbers with a 1 in the first position. Okay, so we say for let j equals 0, j is less than numbers dot length plus, you know, the Copilot stuff here. We want to create this like numbers length thing first. So let's create like a new numbers array here. Numbers filtered is equal to, we just say that. And we say if numbers of j at I is equal to gamma at I, then this number has a digit in the correct position. So we will add numbers filter dot push numbers of j. And at the beginning, let's just say this is an array. Okay, so this means we've gone through every digit and we've added that number. So after we've gone through all the numbers for the first digit, then we have this list of numbers right here. After this, we want to say numbers equals numbers filtered, right? Okay, so let's do, I just want to log this and see where we get to with by the end, by just doing, so essentially this should give us the oxygen generator rating. We're hoping to end with 10111. So let's see what happens. Okay, so we end with an empty array, which is not so good. Okay. Let's see. It's console.log numbers at j, not at I. Numbers at j and I again, and this is in test. Cool. Oh, numbers at, yeah, numbers at j right there. So we have each number, and we're looking at the first bit. Are those ever equal? Okay, so it never passes this, which means probably just equal. If one's probably a string and the other's a number. Correct. Okay, sweet. Yeah, just some typing issues here. Like some type issues. So we have the correct 10111. We have 10110. Let's see. Keeps the number with a 1 in that position because there's an equal number. Okay, let's print out gamma and see what we have. One zero one one zero. Okay, and I think we want that to be 10111 in this case because there's an equal number in the 5th position. 0, 1, 2, 3. Yeah, in the 5th position. So when there are an equal number, this gamma should be a 1. So why is it not? Let's see, we start at zeros. If it's equal to 0, we subtract. And if it's equal to 1, we add. So at the end, if it is 0, then we should return a 1. Don't need to print that. For each digit in gamma, so each of these 1, 0, 1, 1, 0. Let's print out all the numbers just to see what we have. Zero, 1, 1, 1. So this is the number that we should be filtering out, not the other one. See if it's greater than. Oh, what do we print at the end here? Okay, let's print numbers as we filter them. Because as you can see, we're filtering, and then we got this. Yeah, and we filter the 111 out. But we shouldn't be doing that. So gamma here is just set to like an incorrect value. X is equal to 0, it should be 1. Still, it's not. So what if we do that? What do we get? Something completely different. Still. I see. So I think we have to reevaluate gamma and epsilon at each interval. So we do power consumptions every time we filter the numbers list. And so now we should see, let's change that back to equal to 0. And now we have the correct number. Sweet. Okay, so now we have the oxygen generator rating. And now we're going to do the same thing, but with epsilon. And so let's not use numbers here. Here we'll use we'll call this like oxygen, sure, is equal to numbers. And I think I'm actually just gonna go ahead and do this just in case there's any like fanciness going on with like copying by value or value versus reference. And we'll probably have to do the same thing for the other one, which is CO2 is equal to numbers. And so instead of numbers here, we're going to use, I think we want, oh, I see. Yeah, let's just change this to oxygen, 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 oxygen. Cool. So at the end, that's all that's left. We redo this. We have to reset gamma and epsilon with power consumption of, now we're going to do CO2. So let's do that here. See here we're using oxygen, here we're doing CO2. And so all of these values will be CO2. Cool. And then let's see, can we console log oxygen and CO2, see what we end up with. 10111 and 10111 again, which isn't good. Because I think here we were actually comparing gamma, we never switched this to epsilon. Ooh. Where did that happen? Length equals numbers of 0 dot length. Oh, and it might be undefined, so in case it is, let's just return can't read. Oh, numbers empty array. Let's see. If 0, then we'll return just like that. And we can just return like an empty array. Oh, I see, and then you get nothing. Okay, let's do this. And then, okay, we want to actually stop. So instead of doing this, we want to stop both of these loops if and when this oxygen array is equal to like nothing, essentially. So we'll say if oxygen.length is equal to 1, then we're done. Then we want to break. Do the same thing right here. If CO2.length is equal to 1, then also break. Cool, so we have some values, and those look like the correct values from the test. We'll go here, and we will, they want those two numbers multiplied together, I think. Yep, okay, so return oxygen times CO2, and that gives us life support numbers. Let's confirm that we get 2/3, yeah, we gotta parse ints here. Oxygen, CO2, right, those are strings, yeah, so we wanna go parse int, again, base 2, and same here. And we wanna multiply those together, 230, and that's what the example input here said, 230. Now let's switch this over to be the real input. Run it again, get this number, submit. Fantastic, awesome. So that is day 3. This was definitely longer than the last one, but thanks for tuning in, and we'll do day 4 tomorrow. Like I mentioned, these do get hard pretty quickly, and I think there were some pretty simple errors here that I ran into that hopefully I won't run into next time. But yeah, thanks for tuning in. Looking forward to day 4 tomorrow.